Alright, welcome back. Today we're going to learn another shortcut that can prove that triangles are congruent rather than having to prove that all three sides and all three angles are congruent. So this shortcut is called side angle side. So in this postulate it says that the angle formed by two sides of the polygon is called the included angle. And I'm going to be very specific here because the only time that this postulate works is if you have a side and the included side. So it's kind of like this crocodile. You have to it has to be the angle between the two lines. So if two sides and the included angle of one triangle are congruent to two sides and two sides and the included angle of a second, then the triangles themselves are congruent. So again, when you're trying to use this proof, you want to just make sure that you can do some labeling. You look for sides that are congruent, you look for angles that might be congruent, and again, this angle had to be between, it had to be connected by these lines. So here we'll go through an example of a proof. And so in this proof we know that we are going to be trying to use side angle side, so that's going to help us, and probably is going to be the reason down here. So let's look. The wings of one type of moth form two triangles. Write a two-column proof to prove that triangle FEG is congruent to HIG. Alright, so let's look at what we're given. So we're given this piece of information, so we just write given. It's also stated that G is the midpoint, so that is also given. Now look for the clue here. Since we know that it's a midpoint, we have enough information to state something about the two sides of the line. So let's just look at EI first. So here's EI, and it tells us that G is the midpoint. Well, that means that these two segments must be equal. So if we again look at, let me use a different color, let's look at this one, FH. So if we look at FH here, it again tells us that this is the midpoint, which makes these two congruent to each other. So that's pretty good, because now I have at least my two sides. So the question is what am I going to write on these lines? Well, I'm just going to write what I marked. I'm going to write that I saw that EG is congruent to GI, and on the next line, I'm using the blue line there. I marked that FG is congruent to GH. So that's pretty good. We got two sides so far. And we know that we're going to be trying to make a statement about an angle. So here's the step, and we haven't really discussed why this is going to be true. So let's look at FGE. So that's this angle here. Well, it works out that it's the connected angle, so that's good. And then we look over here, HGI. Okay, so you have to remember, we've been putting tools in our tool belt since the beginning, and this relationship when we have two intersecting lines is vertical angles. So when we look at our getting that third side, we know that these are going to be congruent because we have learned before that this is the definition of vertical angles. Alright, and again, once we have the two sides and the included angle, that's enough to prove that we have the triangles that are congruent to each other. And again, we have two sides and the included angle. Alright, so this next one we're going to go through. It says we want to prove that these are congruent, and it tells us that ABG, so let's go find that, ABG, so it's this angle here, that is congruent to angle C, I want to use this color, CGB. Okay, so these guys are congruent to each other. So that's good. We need the sides then. Okay, so let's look at what else we're given. It tells us here in this given statement that AB is going to be the same as CG. Okay, well, guess what? We only need one extra line. We need to have one line. So again, we saw in the last one, this line is itself, right? So if you look at this statement, Well, what property is that we can say that it looks the same on the left and the right? Is our reflexive. Alright, so this one I have to change a little bit because we don't have enough tools right now to be able to go this extra step, so we're just going to prove that the triangles are congruent here. So one clue here is, if you're given that the lines are parallel, you should be thinking about, what did we learn before about angle relationships? Because those will help us prove that parts might be congruent. So we could use alternate exterior, we could use alternate interior, and such like that. So we know that they are parallel. That's what these little markings here mean. They want us to also note that RQ is the same, well, they have a little mark right here, is the same as ST. Okay, so far so good, and let's go with the reasons here. This is given. We know that, well, they tell us that QRT, so let's figure out where that is. QRT, that's this angle here. They say that that angle is going to be the same as ST, or RS, sorry, S, did that wrong, STR. Okay, so this angle here is going to equal this angle here. Okay, so a clue here was that we had that these lines were already parallel. Okay, so if I drew these out, what's the relationship between those angles? Well, look very closely, those are called alternate interior angles. Alright, so the next one, again, we have this thing where they are reflexive, so I'll put that there. And lastly, see if we have two lines yet. So, I don't know that this is correct either. So, let's see. We had that these two lines were congruent. We just proved that these two lines were congruent. And this angle and this angle are the same. So we actually have enough. We don't even need this whole line right here. We have enough information to prove that the triangles are congruent, and this is a side angle side. Alright, last one. We're just trying to make this statement, so it comes from this statement here, and we want to know, how do we get, what's the reasoning I can get from that point? So let's take a look at the picture. It tells us that C is the midpoint of DB. So they're making a statement that DC and BC are the same. Well, we can say that because that's the definition of midpoint. Alright, so today you're going to be practicing with some examples with side angle side.